Hello everyone and welcome to this video. Today we're going to learn how to draw condensation polymers. At the end of this video, you should be able to draw the structural formula of different condensation polymers and deduce the monomers that make up different condensation polymers. Before we begin, you can download the worksheet that accompanies this video. So just click on the link below before we start. Unlike addition polymerization, condensation polymerization involves the loss of small molecules, and in many cases, this molecule would be water. And we will see how these molecules are actually produced when different monomers actually combine together. There are generally two ways in which condensation polymers can be formed, and I use the analogy of a jigsaw here to show you. In the first example, we have two different kinds of monomers. So we have the first one here, and this monomer has two of the same functional group on it, and the second monomer has two of another different functional group on it. Okay, and when they join together, it looks something like that. So basically, you can think of it like a jigsaw. You need one that protrudes out and one that goes in. Of course, this is just an analogy. So the letters A and B here represent two different functional groups. Okay, and we'll see what they are later. In the second case, you can have just one molecule, okay, or one monomer, and on this molecule you have two different functional groups, A and B. Okay, and you just need one type of monomer for a polymer to form, so they can join together in this manner. So what do we see so far? We see that in order to form a condensation polymer, you need two different kinds of functional groups. Alright, and this table below will show you what functional groups we are looking at. The first row. The first functional group could be a carboxylic acid, and the second one could be an alcohol, or vice versa. And when a carboxylic acid reacts with an alcohol, you know that esters are formed. This is from the previous chapter. Okay, in the formation of an ester, you know that a water molecule is being removed. What is important for you to note here is that the OH in the water molecule comes from the acid, and the H in the water molecule comes from the alcohol, and this is always the case. In a similar scenario, we have a new kind of functional group known as an acyl chloride. And acyl chloride actually acts like a carboxylic acid, just that the OH here is changed to a chloride, okay, or chlorine atom. And it also reacts with alcohol, and this acyl chloride provides the Cl, while the alcohol provides the hydrogen, and you can guess that when these two combine together, I remove HCl. This example, which I have marked with a star here, is quite rare. Okay, usually we focus on the first one in our syllabus. So basically, these are the two ways we can make an ester. We go now to example 3 and 4. Another possibility would be involving a carboxylic acid and another functional group known as an amine. And amine is basically this NH2. Okay, we can write it this way, NH2. And similar to how an acid combines with an alcohol, the acid always provides the OH, while the amine provides the H. Okay, this removes water when they join together. And the resulting linkage is called an amide linkage. Okay, so amide linkage is the CONH. And a water molecule is removed for every linkage that is formed. Alright, just like the previous example, we can replace the OH with a Cl, giving us the functional group known as an acyl chloride. Okay, this can also react with an amine to form an amide linkage, and in this case, like previously, HCl is being eliminated. So examples 2 and 4, rarely we see them in the syllabus, but of course it is good to know. Okay, you may ask, why is it I need such specific functional groups in order to make a polymer, in order to make a condensation polymer? The explanation is something that you will learn later in a more advanced chemistry course, but I just explained briefly. In order for certain molecules to react in organic chemistry, you need something known as the nucleophile and an electrophile. So the alcohols and amines, they serve as good nucleophiles, whereas your carboxylic acid can serve as an electrophile. which draws the nucleophile towards it. Okay, but we will leave that explanation for later. For now, for O-level syllabus, we need to know that this combination of functional groups, most importantly acid and alcohol, acid and amine, will give two different kinds of linkages, your ester linkage and your amide linkage. And if you have many of these functional groups together, you can have a polyester and a polyamide. And you can just link them up indefinitely. Okay? We're going to look at some examples now. So we touch on polyester first. Okay, we make a polyester when we have a molecule containing the carboxylic acid functional group and also the alcohol functional group or the hydroxyl functional group. Okay, so one example would be something like that. Okay, and this we call a dicarboxylic acid because there are two carboxyl functional group on the same molecule. Okay, and we react to it with an alcohol. Okay, take note, when these two join together, we have a water molecule that is being removed. The OH comes from the carboxylic acid, whereas the H comes from the alcohol. Okay, and since this is on the other end, you can imagine it connecting to another one over here. So we will cut this part and we will cut it out, this part. Okay, this will join to another one. So it's like a jigsaw, they join together indefinitely. But we can draw one repeating unit in this way. Okay, we start with this part here, which we will keep. Okay, and take note that this will join now over here. Okay, and since this will be joined to another one, we'll just cut it off here. So we can extend the lines like that. And similar to how we would draw addition polymers, we put the brackets in and the letter N. One of the examples of a polyester that we encounter in the syllabus would be terylene. And terylene is being formed from these two monomers. Okay, one is a dicarboxylic acid and one is a diol. So how do we draw the resulting polymer? I want you to draw one repeating unit. You can try first, pause the video before we go through the answer. Okay, so again, in blue, these are the atoms that will be removed as water when the monomers react. Okay, so on this side, we'll cut off here, we'll cut off here. So that leaves us with this and this, which we will join together. So there you have it, this is the resulting polymer. You may have read that terylene, the polyester, we use it for making clothes and sails for boats. These are just some applications. Okay, you can read up more about that. Okay, let's check our understanding thus far. Okay, the first question, which is taken from one of the O-level questions. Which alcohol and acid could react together to form a polyester? So previously, we learned that a polyester is made up of monomers containing the acid, carboxylic acid, and another one, an alcohol. Okay, and back to the jigsaw. Okay, we can have different scenario here. We can have either one monomer containing both of the same one and another one containing both of a different one. Or we could have one that is, you have one of this and another of that. Let's look at the options. Okay, we have an alcohol here. Alright, in option A. So this is a diol. But you look at this monomer, there is no way I can continue joining because there is nothing on this side. So you will liken it to a jigsaw puzzle with, only one end, and the other end, there's nothing that can join to it. Alright, so A is out. So B, you have a diol and a dicarboxylic acid. This would give us a polyester. So B would be the answer. Okay. Let's look at option C. Option C, you have a monomer with, an alcohol here and an acid here, and the other one contains both of the same one acid. So there is no way you can keep joining them together. Okay, so again, like previously, the jigsaw would just end there. Okay, the same goes for option D. You have an acid here, acid with an alcohol, we have an acid. So you can probably only join this together, but the ends are dead already. You can't join anything at the ends of this molecule. Let's go on to question 2. On the combustion of terylene, which mixture of gases will be formed? Let's recall terylene is a polyester. So there are only these 3 elements in terylene. So when this burns in oxygen, undergoing combustion, I shouldn't see any molecules containing nitrogen. So that rules out B, C, and D. Okay, leaving option A as the correct answer. Okay, so far? Alright, we are going on to polyamide, which is essentially the same. Okay, just that we change the alcohol to the amine group now. So the first example, a dicarboxylic acid, and now we combine it with an amine. When these 2 molecules join together, a water molecule is being removed. Okay, so remember that the amine gives the H while the acid gives the OH. We'll now put these 2 groups together, okay, to give us 1 repeating unit. Doesn't really matter whether you draw the H up or down. This is 1 repeating unit. If they ask for the structure of the polymer, you must remember to add in the brackets and then an N. And the linkage here is known as an amide linkage, CONH. One example of a polyamide would be nylon. Okay, and this nylon is called nylon 6,6. There are different kinds of nylon. You can go online to do a search on the different kinds and see if there's any pattern in the structures. Basically, the numbers here 6,6 refers to the number of carbon atoms in the monomers. So we have the first monomer here containing 6 carbon atoms, and the second monomer also contains 6 carbon atoms. That's why we call it nylon 6,6. Of course, there are many variations. Given this, how would we draw the structure? Okay, same thing. Your amine provides the H, acid provides the OH. Okay, so just like this, we're going to replace the boxes now with the atoms that are actually inside. What you have here is 1 repeating unit of nylon 6,6. Okay, and this repeats many times. So if you are drawing the structural formula, we'll put in the brackets with N. So you may already know many uses of nylon, and in many instances to make fishing lines or cloths, pants, or parachutes, okay, so on and so forth. Okay, now let's look at some questions. We have a structure given here. On the first look, we know this is a polyamide. How do we know that? Because this is the amide linkage, CONH. How would one monomer look like? Okay, this will be the structure of the first monomer, because a box with what looks like from a carboxylic acid and what looks like from an amine. Okay, and on the other side, you have an amine, and this joins to, we go back from head to tail again to this. So what are the 2 monomers that make up this polymer? Okay, the first one is here, the second one is here. We take reference from the boxes. Okay, we draw number 1 first. So CO means it's carboxylic acid, and H comes from an amine. So we have first monomer with 2 different functional groups on the same molecule. Okay, the second one, okay, on the left hand side here is your amine again, and on the other side we have a carboxylic acid. Okay, and these join together, alternating back and forth, okay, to form a polymer. Let's look at the options. It is a polyamide, yes. It is from the monomers this and this. No, that is not correct. This is actually a condensation polymerisation reaction. The structure is not nylon, because nylon, you are using a dicarboxylic acid and a diamine. This is not the case. Question 4, a little bit more challenging. How many of these monomers will react the molecule below to form a polymer? We have a diamine and a dicarboxylic acid. Definitely they are compatible. We have a carboxylic acid and an amine here. carboxylic acid. You can't, because you have too many of this. The moment this reacts with this, that's it. The chain stops there. Okay, so this one will never be able to form a polymer, even though this and this could react. Okay, what about this? Alcohol reacts with acid, amine reacts with acid. So this is also possible. You can join them end to end. Okay, and the diol will always react with dicarboxylic acid. So the answer here would be C. So for drawing addition polymers, you need to look out for two different functional groups that react and make sure that on your different monomers, these functional groups are able to link end to end and not stop. Okay, let's recap the steps before we end the lesson. You may not always be given molecules that are drawn nicely for you. So in this case, you always want to draw them such that your functional groups are on the left and right. This will make it easier for you to join the molecules together. Okay, so I'm looking at a carboxylic acid here, carboxyl group, and the hydroxyl group. Okay, I want to draw them at the ends so that when I remove the water and join them together, it is much easier for me. Okay, after you have lined them up like that, remove water, join them together. Of course, don't forget to cut off the ends at the appropriate places. Okay, what you have here without the brackets is one repeating unit. Whenever the question asks for the full structural formula, you have to show all the atoms expanded like that. Okay, so you cannot condense it in this manner. So take note of the question requirements. When you are asked to draw the structural formula, put in your brackets and the letter N. So here are 5 questions for you to practice as an exercise. So try them out and I'll give you the answers shortly. Okay, let's check our answers in the first one. We expand out all the bonds so it's easier for us to see. Okay, and we have a diol and a dicarboxylic acid. Okay, remove water, add the lines and brackets. Fairly straightforward. So what we have here is a polyester. In the second question, you are starting from this. This looks like a polyamide. We cut the molecule at the amide linkage, so giving us the first one. Moving backwards, we will now add in the hydrogens at the ends, okay, for the amine, and we'll add in the OH for the carboxylic acid part. So then we'll get these two answers. Okay, question 3 is one where you only have one monomer, but you have 2 of the required functional groups on the same monomer. So this can join end to end. Remove the OH from carboxylic acid, remove the H from the amine, you have a polyamide. Question 4, like question 3, you have 2 of the required functional group on the same monomer. We can remove the OH here, remove the H here, and join them together. Okay, question 5 is one involving the acyl chloride, which I've mentioned at the start of the video. So when you see this, the Cl acts like the OH in the carboxylic acid. Okay, you remove it with H, okay, to form the polymer. The small molecule eliminated here would be HCl. Alright, so I hope this video was helpful to you. Okay, it takes a lot of practice, so go and try the questions in your 10-year series to reinforce your understanding of this chapter. Thanks for watching.